Hello everyone, welcome back to my YouTube channel. Today we are going to study about infrared spectroscopy part 2. In this IR part 2, we are going to learn about how to interpret of IR spectrum. So as you remember before, the detector is connected to the computer, and then the output you will see this spectrum. We call this is IR spectrum because the computer connected to the infrared spectroscopy. So we call this is infrared spectrum. As you see here, there are two axes. X-axis we call it as wave number with the unit is per centimeter, and y-axis is for the absorbance in percentage. It means that how many infrared spectrum, how many infrared light will absorb by the sample in certain functional group. So there is the weakness of these spectrums. We only can check the presence of functional group. That's it. As you know that each type of vibration will absorb the characteristic wavelength of infrared radiation. We cannot be too specific when quoting the characteristic absorption frequency of a bond. The nature of the rest of the molecules shifts the energy absorbed in each particular molecule. Therefore, we can identify the presence of the functional group from the absorbance pattern of infrared spectrum. So of course we need this table. This table called as some characteristic infrared absorbance bands and their intensities. So as you know here, which one is bands? We call this is bands. So we only analyze the bands that show in the spectrum. So here, no need to memorize this table because usually in your exam, table will be given for you. So in here, you only need the skill of analyzing, how you are able to analyze the spectrum and then match with the table. That's it. Okay, for example here, the table, it's already start from bond. For example, there is C single bond O. The functional group that may contain in this probably alcohol, ethers or esters, and then the wave number in this range. The appearance of the peak S means that strong. Is it strong or weak? Okay guys, so I think you know how to read this table now. I will explain through one example. Example 1, as you see here, there is infrared spectrum of ethanol. As you know, the structure of ethanol is CH3CH2OH. So we are going to analyze the presence of the functional group inside this ethanol. As you know, the functional group of the ethanol is hydroxyl group or OH. So we go back to the table. OH, alcohol, it's in the range of 3,200 until 3,600 wave number. So you look at here, is there any band with strong? This is strong peak. So yes, there is a band between this range 3,200 until 3,600. We call this. So when you see this band, so we call this is as OH functional group. It means that in this wave number, there is functional group of OH that the absorbance is around 90%. Okay, that is the meaning of this spectrum. So if you want to match the spectrum with the structure of the molecule in the future, just check the bands and analyze the structure. That's it. I'll give you another example. We have infrared spectrum of ethylamine, CH3, CH2, and H2. So we want to check the presence of functional group of amine. Amine is NH. So this is amine, NH. NH, the wave number is in the range of 3300 until 3500. Is there any bands with the appearance peak is weak? Weak means that broad. So here the range of 3300 until 3500, there is a broad band here. We call it as NH or amine. So we can say that there is the presence of functional group for amine in the spectrum. So we can say that this spectrum belongs to ethylamine. One more time, I told you there is the weakness of IR spectrum. We only able to check the functional group, not the presence of H2 or the presence of carbon. If you want to check the presence of each element, you're gonna study that in A level for NMR, carbon NMR, and proton NMR. I mean that we're going to use another instrument called as NMR. Okay guys, I think that's it for my explanation for today. I wish now you're able to interpret the infrared spectrum in the future. Bye.